This video is for lesson 9-1, transformations. We're starting a new unit about translations, reflections, and rotations. And here's the first lesson. Learning goals are to perform transformations on the coordinate plane, identify characteristics of transformations that are rigid motions, and characteristics of transformations that are non-rigid motions, and represent a transformation as a function using coordinates. Mr. Scott directs the Marching Cougars, the band at Chavez High School. He uses the coordinate plane to represent the football field. For the band's first show, he arranges the band in a rectangle that is 6 marchers wide and 9 marchers deep. The band begins by marching down the grid in this formation. Then the marchers move apart from each other vertically while keeping the same distance between marchers within the same row. The diagrams on the next page show the initial shape of the marchers and the 2 transformations that they undergo. To describe and classify the transformations, compare the pre-image of a transformation to its image. So here we're using this example of a marching band and their formations to bring us into the geometry topic of transformations. Here are those drawings. We have the original rectangle filled with the band members. Remember, they were dots on the grid. And then they move in a group to create this arrangement on the field. And then the next transformation, they move in a group, kind of stretching out this way and this way, increasing the space between the people. Number 1, use your own words to describe transformation 1. So what happens from the pre-image to create this image? Looks like the rectangle slides downward. Number 2, compare transformation 1 and transformation 2. How do the 2 transformations compare? Well, transformation 1, that rectangle is the same size and shape as the original rectangle. But in transformation 2, the rectangle has been stretched. And so that's what I answered here in purple. Number 1 preserves the size and shape of the rectangle, but number 2 stretches it. Okay, question 3. Transformation 1 is an example of a rigid motion. A rigid motion keeps the same distance between the points that are transformed. In this situation, those points are the marchers of the band. The shape and size of the pre-image and the image are the same. Question A. How does transformation 1 affect the distance between any 2 marchers in the band? And the answer is that that distance stays the same. If we go back to this picture, remember this rectangle was really made out of dots, right? Each dot was a band member. And then after the transformation, these dots are all still the same distance apart. Question B. How does transformation 2 affect the distance between the marchers? And is transformation 2 a rigid motion? Well, what happens is that the horizontal distance between points stays the same, but the vertical distance is increased. This is not a rigid motion. To go back to the picture here. Here we had what the rectangle looked like after the first transformation, and now here comes transformation 2. Horizontally, the distance between these dots stays the same, but vertically, the distance is doubled, right? Here is one of the people in the band, and then here's the next person in the band. That vertical distance has been stretched. That's not a rigid motion. It doesn't rigidly hold this rectangle to the same size and shape when it's transformed. Number 4, review transformation 1. Each point in the pre-image is mapped to a point in the image. For this reason, the transformation can be expressed as a function. Complete the table below to show the positions of the 4 corners of the rectangle when figure A is mapped onto figure B. So you notice the 4 corners of figure A. They're at 1, 10, 1, 2, 6, 10, and 6, 2. If I show you that picture again, you can see where those came from. Right here is 1, 2. Here is 1, 10, 6, 2, 6, 10. After the transformation, Here are the four corners. So what this question is asking is, what are these four ordered pairs? For example, this dot in the upper left corner is 1, 4. And so in the chart, I have filled in the corners of figure B. Question B, for any given point, how does the transformation change the x-coordinate and the y-coordinate? Let's look at the x-coordinates. That x-coordinate is 1. After the transformation, the x-coordinate is 1. That x-coordinate is 1. After the transformation, the x-coordinate is 1. That x-coordinate is 6. After the transformation, that x-coordinate is 6. The x-coordinate stays the same. But the y-coordinate decreases by 6. Saying that the y-coordinate decreases by 6 is another way to say that that rectangle has moved down 6 spots. Each of the four corners will have moved down 6 spots. Question C. You can use the notation 1, 10 is transformed, or notice over here on the side how to read the arrow, goes to, so let me try that again, 1, 10 goes to 1, 4 to show how a point is transformed. When you use this notation to show how a general point, where you're using x and y instead of specific numbers, you are expressing the transformation as a function. Express transformation 1 as a function. Here's what it looks like. X, y goes to, or is transformed to, x, y minus 6. I've taken those observations and written it using algebra. Let's try this again back on that original picture and look at transformation 2. So we have question 5. A. Complete the table below to show the positions of the four corners of the rectangle when figure B is mapped onto figure C. So here are the four corners of the rectangle in figure B. When it was stretched vertically, here are the ordered pairs for the four corners. We can quick go back and take a look at the rectangle, and you can see that. So here was figure B, and here's figure C, and so that corner is 1, 8. This one is 6, 8. This is 1, negative 8. This is 6, negative 8. That's what that question was asking for. What are the corners? And those are filled in the chart. So for any given point, how does the transformation change the x-coordinate and y-coordinate? Let's do the x's first. 1 and 1, 1 and 1, 6 and 6. What's happening to the x-coordinate? There's no change. That's not the case for the y-coordinates. That y-coordinate is 4 and that's 8. How did it change? That's negative 4 and that's negative 8. How did that change? Again, 4 and 8. Do you see what's happening? It looks like that the y-coordinate is being doubled. 4 times 2 is 8. Negative 4 times 2 is negative 8. So the y-coordinate is doubled, or is multiplied by 2, is another way to say that. Question C, can transformation 2 be expressed as a function? Explain why or why not, and write the function if it exists. And the answer is yes. It can be written as a function because each point of the pre-image can be mapped to a unique point in the image. We saw that with the four corners of the pre-image. They can be mapped to these new four corners. And that would be the case for any other dots that would have been on that original rectangle. They would move to new locations to create figure C. Here is the function written out using algebra. X, y goes to x, 2y. Notice the 2y is how you show doubling. Number 6, draw each image on the graph to show how the pre-image is transformed by the function. Then classify the transformation as rigid or non-rigid. So we have this square, and here are its four corners. This one right here is located at 2, 2. This one here is 1, 2, 3, 4, 5. This is 5, 2. This one is 5, 5. And this corner is 2, 5. And we want to adjust those ordered pairs using this formula. So it looks like that the x value is going to be increased by 3, but the y values of the points will not change. So let's follow those instructions to create the new shape. So that corner, the x value will increase by 3. That's going to become 5, 2. It's like moving 3 spots to the right. That corner there, again, the x value is increased by 3, but the y value doesn't change. That will become 5, 5. That will become 8, 2. And then that one will be here. And so here is the image. This square was the pre-image. We did this transformation, which causes it to slide to the right 3 spots, but not to affect anything vertically, and that creates this square. So is it rigid or non-rigid? It is rigid. It maintained the same size and shape. Question B. Let's take points, x, y, and transform them using this formula. Double the x and double the y. Let's do this by, again, moving the 4 corners. Those are the easiest ones to move and then redraw the shape. So this dot is at 1, 2, and we want to double the x and double the y. That will become 2, 4. Okay, this dot here is at 3, 2. Let's double the x and double the y. It will become 6, 4. So 1, 2, 3, 4, 5, 6, 4. This one right here is at 1, let's see, 3, 4, 5. This is at 1, 5, so we double the x and the y. That would make 2, 10. So 2, let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10's way up there. So there's that corner and then that corner. So we connect these together. This creates the image. And again, we were asked, is this a rigid or non-rigid transformation? This is a non-rigid transformation because it did not preserve the same size. Okay, number 7, write the numeral 4 in the middle of each pre-image and describe how the numeral should appear in each image. So let me go back to this first one. We're supposed to write the number 4 in the middle of this. When we transform this by moving the thing to the right 3 spots, notice that the number 4 would just keep the same size and shape. In a rigid motion, size and shape doesn't change. Okay, this next one, if we were to write a number 4 kind of in the middle of this like this, but we perform this transformation where things are doubled, the idea is that that 4 would end up doubling. So describe how the numeral should appear in each image. In the first image, it stays the same size and shape, but in this second one here on the screen, that numeral 4 would keep the same shape, but it would double in size. Here are some check your understanding questions, so I will pause the video. Okay, in this lesson we were introduced to transformations, which is the topic of the entire next unit. We looked at transformations involving a coordinate plane, an x and y axis. We talked about rigid versus non-rigid transformations, and we even brought algebra into the mix by working with functions and looking at the ordered pairs of the corners of the shapes.